All right, guys, grade 7s, this is your study guide for the measurement test that should occur probably Thursday of next week or this coming week. You know the drill. I'll give you the questions. I would then ask you to press pause, do the questions on your own, and then just scroll through it to make sure you have the same answers as I do. And if you have a problem with a question, you can listen to how it's done and then come see me after you've tried it, after you studied it. These study guides are good for you to prepare for your test, but there has to be some work done on your part. You will not be getting a study guide next year if you're in grade 9, or if you have another teacher other than myself. You'll have to go into your notes and your work to find these type of questions and test yourself. You cannot study mathematics by simply looking at it and saying, okay, I know how to do that. You actually have to do them without assistance, and to prove that you know how to do it. If you don't, you go back and study it a bit more. So first thing I'm going to do is I'm going to move these shapes so I have room to work, and we'll get started. You should press pause. Here's the first question is this rectangle, and I better put some measurements on this. We'll call this 10 centimeters right here. And here are your shapes. And go ahead and quickly draw them out, and we'll get started. Put your labels on, press pause, and let's go get it. Okay, so when we look at the first two, the perimeter of a rectangle, we're going to use side 1 plus side 2 plus side 3 plus side 4. There are other formulas like 2 times the length plus 2 times the width, but I find that really confuses kids and gets them thinking into area, and our formulas are all over the place. So in this case, it's a rectangle. We're just going to add up all the sides because perimeter is the outside of a shape. If there's my rectangle, 46 centimeters squared will be my area for it. In this triangle shape right here, I have 9, 9, and 10 as my sides. Same thing, perimeter is side 1 plus side 2 plus side 3. I add those three together, and I get 28 centimeters. Now that I look at this, I was going a bit too fast. That is 46 centimeters. It's not squared at all. That's area. Okay, so now we get into a couple of our harder shapes, and we're going to do a circle and an irregular shape. With a circle, we know that the perimeter of a circle is actually called circumference, and circumference has a formula of pi times diameter. Pi is the number that is always the same. It's 3.14. And the diameter is the distance all the way across a circle through the midpoint. If 7 is my radius, we simply multiply 7 by 2 to figure out that the diameter that I'm going to need is 14. Now that I have that, I can simply multiply the two numbers, and that equals 43.96 meters. And there's our answer for that one. And lastly, we have an irregular shape, so you have to start deciding what parts of this you're going to add. I need this part of the circle and this part of the circle. I'll also need this part of the rectangle and this part of the inside rectangle. Apparently this is a hockey rink, or well, it's pretty long for a hockey rink, but a track and field zone. I'm not quite sure what it is. I don't know, 40 meters, probably a hockey rink. It's a hockey rink. Anyhow, so we're going to have to separate this into two pieces. Let's start by doing the perimeter equals side 1 plus side 2 plus side 3 plus side 4. In my diagram, I'm okay. I know that that's 40, so this length here will most likely be 40. It's a rectangle. They'll be the same. The only parts I don't know at the moment are these half circles. But half circles are simply circumference, so I have to use my circumference again. C equals pi times diameter. And in this question it says that the radius is 10, so I put 3.14, so yep, 10, so my diameter is going to actually be 20, and actually you can see it right here, that's 20, that's all the way across, and 3.14 times 20 is 62.8, and I guess in this case it's meters. So I would add that to my diagram, 62.8 and 62.8 meters. And now I'm able to do my formula of adding all the sides. So I have 62 decimal 8. I'm going to add on 40. I'm going to add on 62 decimal 8. And I'm going to add on 40. Those are all my sides. If I want to do this, because I have substituted values that I know. And my total answer is 205.6 meters. For the outside of that, I guess it would be a hockey rink. I'm not quite sure. Here we go. Next value. Next page. Okay, so now we're going to move into area. Same thing. Take a quick second to copy all these down, and then I'm going to hit pause. I'll have them all answered for you, and away you go. So go ahead and hit pause. All right, so here's our area questions. Remember, all your area formulas will be given to you right on the test. But anyhow, area of a rectangle is length times width. You multiply the two, you get 57 meters squared. There's that one. Over here on the triangle, you have to decide which one's the base and which one's the height. Remember, it's these two. It comes off of the right angle. This one here is the hypotenuse, and we do not use it for these questions. You'll find them in questions in diagrams, but we do not use that information for area, only for perimeter of the triangle. So we're going to use 6 and 6. We use our formula base times height divided by 2, and at the end we get 18 centimeters squared. Moving down to the circle, our formula of area of a circle is pi times r squared. Please remember that r squared is r times r, radius times radius. Anything squared is times itself, not times 2, which is a common mistake that kids make. Anyhow, you fill in all your stuff. Oh, by the way, we had a diameter for our circle. We had to find half of that in order to find our radius, and we did that at 2.4. And finally, when we multiply 3.14 times 2.4 squared, which was 5.76, our final answer was 18.09 meters. Still not bad. You were doing great at this in class. And lastly, our irregular shape. What you had to do with this is you can see that there's two rectangles. Divide them into two rectangles, and then make sure you find the missing value. I was able to find that this was 8 because the whole length from here to here was 12, and this was 4. So I just subtracted 4 from 12, and that was able to tell me that this piece here was 8. Once I knew that, I did the first area, the second area, got 16 and 56, added the two together, got me 72 meters. You're going to do great with that one. Moving on to volume of a prism. And we have three different, actually one's actually a cylinder. And I'll move it up here. Put my pen down, I'll move it up so that you can quickly copy or sketch these out before we get started. The trick to this, it's a universal formula. We're going to use the same one every time. That volume is equal to the area of the base times height. That's not too difficult a formula to remember. The only thing we have to remember is for a prism, the triangle is always the base. No matter what it's sitting on, you're going to turn it in your mind and make it the base. On a rectangular prism, it doesn't really matter. If you want to be all consistent, you can put it on its smallest side if you want. But on a prism, a triangular prism, and a cylinder, the base is the circle and triangle. So as long as you get that first, all of these are quite easy. So again, I will move these around, press pause, work them out, check to see if your answers match. Okay, to go over this quickly, you always start with your formula, and we're going to use triangle as our base, like we said with prisms. So there's your formula, base times height divided by 2. It'll end up with an area of 6 for just the base of the triangle, or if the triangle is the base of the prism. And you multiply that by the height of your prism, which is 11, which will give you 66 centimeters cubed. Remember, our volume is always expressed as a cubed answer. All right, our next one is the cylinder. One of the first things I had to do, I wasn't given a radius, but I know I'm going to need one when I do my area formula. So I had to find the area. I was given a diameter of 20, and we know that the radius is half of the diameter. So that's how I was able to get 10 for a radius right here. I put that all into my formula, and I come all the way down. I'm going to get 314 as my area of the circle. Not done yet because I have to multiply it by the height, and eventually I will get 628 centimeters cubed. Lastly, on the bottom, one of the easier ones, but it's a rectangular prism. You do the area of the base. Again, I said it doesn't matter for a rectangular prism, so I just did 12 times 6, used the base it was sitting on. That gives me 72 meters squared. Can't forget to multiply it by the height, 360 meters cubed. Okay, off the surface area. Here are two surface areas, two prisms that we're going to do some work on. I'll let you copy them down, put some space in between them, and then I am going to get started. Please remember, your first thing that you do is you draw a net for these. On your test, you'll get a mark for your net and for all your work. So you have to see how this would look when we take it apart. And it will really help you when you are doing your area. So good luck. Hit pause, and I'll have the answers for you. Okay, so here's our first net. It's our triangular prism. We broke it up. When you break it up, you see that 3 of the rectangles are the exact same size, 12 by 8. And the triangle has a base of 3 and a height of, a base of 8 and a height of 3. So anyhow, to figure out the question, you do the area of a rectangle, you get yourself an answer, and then because there are 3 of them, you simply multiply it by 3, and you'll get an answer of 288 for all 3 rectangles. Why do area of a rectangle 3 times when you can do it once and just multiply it by 3? Anyhow, now there's 2 triangles that you have to add in. You do the triangle of 1, and it equals out to 12 right down here, but then you know that there are 2 triangles, and that comes out to 24. And lastly, in order to do surface area, you have to add up all of your rectangles and all of your triangles together, and when you add up your rectangles of 288 and your triangles of 24, you get 312 centimeters squared. All right, moving right along, because this is getting to be a long video. But here is our rectangular prism. Down here is your net. What you should discover is that we don't have 5 rectangles that are the same. We have 2 pairs, or actually 3 pairs of rectangles if you want to look at it. So we're going to have to do area of a rectangle 3 different times and add them all together. So in here there's the pair that is 12 by 6, that equals 72, and when you multiply that by 2, that is 144. There's also a pair that is 12 by 5. You multiply that to 60, times 2 is 120. And then the small rectangles on the end are 6 by 5, gives you an answer of 30 multiplied by 2 is 60. Put all of those rectangles in this net together, and you come out with a total surface area of 324 centimeters squared. Now we're just moving on to our conversions, and we should be ready for the test, except for word problems, but that's for you to apply this knowledge to. All right, we're up to our mass conversions, and for mass is milligrams, grams, kilograms, and tons. We're using metric, obviously. We're in Canada after all. And something we have to remember from when we did this in class is that these are all based off 1,000. There are 1,000 milligrams in 1 gram. There are 1,000 grams in 1 kilogram. There are 1,000 kilograms in 1 ton. So the number between all of these, get my pen back, the number between all of these is 1,000. That is how we convert between milligrams and grams and kilograms and tons. We use the number 1,000. Your choice, however, is whether you multiply by 1,000 to get the new number or divide to get the new conversion. And you have to say to yourself, logically speaking, if I had so many milligrams, and they're smaller than grams, would it make more sense that I would have even more grams if I was to convert it? And of course it wouldn't. So we know that if we're going this way from milligrams to grams, we are going to divide. But if we are going from grams to milligrams, you're going from something larger to something smaller, you will actually have more milligrams than when you started, so we're going to multiply. And that applies between each of these. If you're going from the smaller to the larger unit, you are going to divide. And if you're going the other way, you are going to multiply. Think it through logically when you do it, and you won't make a careless mistake. So now that we remember how we make our conversions, and sometimes we're actually going to skip over 2 spaces. Instead of by 1,000 as our conversion, we're going to use 100,000. We're going to use 6 zeros. Anyhow, here are your questions. Get them written down on your paper, then press pause, take them up, and we'll move on to our capacity conversions. Here are your answers, and I don't want to spend too much time on them, but kilograms to tons and milligrams to grams, number A and B, you are going from the smaller to the larger unit. So when you go from the smaller to larger, you're going to divide. This one will be 0.54. This will be 3.56. For B or for C and D, we're going from the larger unit to the smaller unit. So we will be multiplying by 1,000, and we get 760 kilograms and 567,000 milligrams, respectively. And lastly, if you had a little bit of trouble with E and F, there are 2 steps. It jumps 2 places. So instead of multiplying or dividing by 1,000, you're going to multiply or divide by 100,000. It's not a major issue. Remember, we just moved the decimal 6 places to the left or 6 places to the right, depending if we're multiplying or dividing. Anyhow, milligrams to kilograms would be decimal 0.006789. And for tons to grams, 5,600,000 grams. All right, let's go do capacity. All right, so here is our capacity conversions. Remember, when you start with this note, I know we had a supply teacher when we did it, but we kind of fixed it all up. A small, tiny centimeter cube is 1 milliliter of liquid. If you take 1,000 of those centimeter cube little cubes, you can put them in 1 decameter. And I showed you a cube at the front of the class that was 1 decameter. Anyhow, that 1 decameter can also hold 1,000 milliliters of liquid. And 1,000 milliliters of liquid can be converted to 1 liter. So there's a couple conversions here. It's centimeters to decameters, centimeters to milliliters, milliliters to liters. They're all related as long as you understand conceptually what a centimeter cube looks like or a decameter cube looks like, and then you're able to see the size of it, and it makes much more sense. Again, we're working with the number 1,000, which makes it much easier to do. Anyhow, now we have 1,000 decameters. We could put them in 1 meter cube. So if I had not 3 meter sticks, but if I had a bunch of meter sticks and I could tape them together to make a cube shape, we could fit 1,000 of those decameter cubes that I showed you in class. Remembering that each decameter is 1 liter, we could then fit 1,000 liters of liquid in one of those meters cubed. And 1,000 liters is also called 1 kiloliter. So that's the basis for these conversions from class. You will have to know that stuff. You'll have to try to remember that. But here are your 3 questions. There are many more examples in the notes that we just did and the questions we did in class. We seem to be doing okay with them, but you might need to practice them a little bit. Anyhow, looks like I forgot to do these as cube numbers. I didn't put them up, but you understand that this is meters cubed and centimeters cubed and decameters cubed, so we'll still be good to go. Go ahead and hit pause, write these down, try them out, and we'll go from there. All right, here we are with our answers. Meters cubed to liters, there was a bit of a jump. It's almost easier to do this part first and do kiloliters first because it's a straight conversion. 34 meters cubed is 34 kiloliters. Remember, there is 1,000 liters in 1 kiloliter. So if there's 34 kiloliters, there are 34,000 liters. That's how we do the first one. In the second one, centimeters cubed to milliliters is a straight conversion. They are equal to each other. 1 centimeter cubed is 1 milliliter. So 456 centimeters cubed is 456 milliliters. But there are 1,000 milliliters in a liter, so we would have to divide that by 1,000 to get the liters, and that will give you decimal 456 liters. Lastly, Decameters again, just the way this worked out, decameters cubed to liters is a straight conversion. They're equal to each other. 1 decameter cubed is 1 liter. So 7.6 decameters equals 7.6 liters. There are 1,000 milliliters in 1 liter. So this time we'll multiply by 1,000 and you get 7,600 milliliters.